This is week 2, and we'll be going over AI topics and how AI evolves. So, today we'll be learning about how neural networks learn, how advanced AI architects such as CANs, LLMs, and diffusion models, AI's roles in scientific discovery, and ethical considerations and future potentials. So, how neural network learns. AI learns by recognizing patterns in data. One way to train AI is by showing it thousands of images of handwritten numbers. To reach it to recognize digits, just like we do, AI improves through a process called gradient descent. Think of it like rolling a ball down a hill. The ball keeps moving until it finds the lowest point. For AI, this means adjusting its setting over and over until it makes fewer mistakes. Even though AI can get really good at this, it doesn't always see things the way humans do. It learns based on numbers and patterns and not the way we see edges or shapes. Now let's talk about cans. Traditionally, AI changes its weights to learn, but cans do something different. They can keep their weights the same and instead change their activation functions, which controls how the AI reacts to data. And cans can use something called B splines, which can help them adjust smoothly and efficiently. This can make AI models simpler, faster, and possibly better at certain tasks. It's a new idea, and researchers are excited to see how it can improve AI. Next, we have um, MIT lecturers, advancements and challenges in AI. So, AI is powerful, but it has some big challenges. The MIT lecture on AI talks about three main problems. Generalization. AI can struggle when it sees something new, but it may be great at recognizing training data, but not as good in real world situations. The second thing is adversary attacks. AI can easily be tricked. Changing tiny details in image can make AI misidentified. And the third main big problem is bias. If AI is trained on biased data, it can make unfair decisions. This is a big issue in areas like hiring or criminal justice. These challenges show that AI still has a long way to go. Next, we're going to look into generative AI diffusion models, how AI creates images and design molecules. One of the coolest AI advancements today is generative AI that creates things. This includes AI art, music, and even drug designs. AI like DALI uses diffusion models to turn random noise into images just like an artist, starting with a rough sketches and refining them into a masterpiece. Scientists are also using this technology to design new materials and making it useful in medicine and in chemistry. Next, we're going to be looking into the large language models or LLMs. Large language models or LLMs power chatbots just like ChatGPT. Now, they read tons of text and learn to respond like humans. They're great at writing, summarizing, and even coding. But they have some big problems. First big problem is hallucinations. AIs can sometimes make things up and sound confident about it. The second big problem is energy use. Training big AI models takes a lot of power and resources. And the third big problem is bias and misinformation. If AI is trained on biased and incorrect data, it can spread false information. Although this is good because we're being resourceful with ChatGPT and using it almost like a Google search, it's not guaranteed to be truthful. So LLMs are it's still useful, but they have a long way of going till it's perfected. So The next slide we'll be going into is AI in science, such as AlphaFold and protein folding. So, AI is also helping scientists solve huge problems. One example is AlphaFold, an AI that helps predict how proteins fold. Why does this matter? Proteins are like tiny machines inside our bodies. Understanding how they fold can help scientists develop new medicines and treatments for diseases. Dennett Demis Hassabis, a founder of DeepMind, won a Nobel Prize in Chemistry in 2024 for this breakthrough, and it's an example of how AI can do more than just chat with us. It can also save lives.